So today we are going to discuss about some questions of JEE Advanced 2025 January sessions. Only section 1 is discussed here. As we all know, there are 3 sections, in which section 1 contains 4 questions. For each correct answer we will get +3, and in case of wrong answer -1 will be given. So here's the first question. A closed vessel contains 10 grams of an idle gas at 300 Kelvin, which exerts 2 atmospheric pressure. At the same temperature, 80 grams of another idle gas Y is added to it and the pressure becomes 6 atmosphere. The ratio of root mean square velocity of X and Y is to be found out from the options. Temperature is 300 Kelvin. So let's see what are given here. For gas X, it is given it is 10 gram and Y is 80 gram. Temperature is given as 300 Kelvin and pressure of X is 2 atmosphere, and after adding Y, pressure becomes 6 atmosphere. So the net pressure of Y is 4 atmosphere. We have to calculate the root mean square velocity. So for a gas molecule, in a chamber, suppose in a chamber number of gas molecules are moving, there can be 3 kinds of velocities. First is average. In average velocity, we calculate the average of speed of all number of molecules. Suppose there are 10 molecules moving, so we just calculate the speed of 10 molecules and average it. Then it's the RMS, root mean square speed. It is when we square the velocities of each molecule and take over the root. That is root mean square velocity of each molecule. It turns out to be greater than average. And another one is the most probable speed. Most probable speed is, suppose there are 100 molecules in a chamber, 100 gas molecules moving in a chamber. The speed of the maximum molecules, that is, suppose there are 20 molecules moving with a speed of 30 meter per second, suppose, then the most probable speed will be 30 meter per second. So the formula of RMS is root over 3 RT by M, average is root over 8 RT by pi M, and most probable is root over 2 RT by M. We can memorize it in the form of RAM RAM. RMS is always greater than average and most probable, and the only difference is from root 2 to root 3. So we are only discussing about RMS speed in this question. RMS is root over 3 RT by M. So for two gas molecules, we are taking the ratio of RMS velocity of X and Y, which turns out to be root over My by Mx. We don't know the value of My by Mx, but from the given values, from the ideal gas equation PV equal to nRT, we convert number of moles in given mass by molecular mass. Here we have to calculate the value of capital M. So we calculate for both gases PV equal to nRT. Pressure of X is given as 2 and given mass is 10 gram. Similarly for Y it is 4 atmosphere and 80 gram. So for X it is Mx is 5 RT by V and for My is 20 RT by V. We have to calculate the ratio of RMS speed, putting the value of Mx and My. It turns out to be root over 20 by 5. It is root over 4, that is 2. So Vx by Vy turns out to be 2:1. Another question is, at room temperature, disproportionation of an aqueous solution of in situ generated nitrous acid gives the species. Disproportionation reaction. So disproportionation reaction, when a reactant disproportionates to a lower oxidation state and higher oxidation state. Here we have HNO2. Here we have nitrous acid. So in nitrous acid HNO2, oxidation number of nitrogen comes out to be +3. So +3 must dissociate into a higher oxidation state and lower oxidation state. Let's see, nitrogen can have oxidation number up to +5. And as long as I think everyone remembers, there's a question in NCERT where it is clearly written that nitrous acid dissociates into nitric acid. So NO3 minus must be there. And H3O plus is common because nitrous acid is acidic. So H plus must be there in solution. So NO3 minus must be there for sure. Let's take out the oxidation numbers. NO3 minus, we know that +5, NO of +2. Similarly, NO2 +4. In NO minus there is +1, and so on the oxidation numbers. Option B can be neglected because both oxidation numbers are of higher value. Both oxidation numbers are of higher value, and I have also said that nitric acid must be must, so it must be between A and D. N2O is very unexceptional where nitrous acid dissociates to N2O, so A must be more common, and here is the answer. +3 dissociates into +5 nitric acid and NO. This reaction is clearly given in P block, chapter P block of class 12. So that's all. Thank you.